Hello. In other videos, we have seen the basic types like the string, number, boolean, interface. In this video, we will cover something little bit more advanced. And before we go to the actual type, we will see how we can do the union of different types. What does it mean? Let's say I have a function called get user details by ID, and it accepts a parameter of type ID, number, sorry. Now I will just print here, fetching user details by ID and call this function, pass a number 100, go to the logs, click on the run, and I have the output. So far simple, right? Nothing special here. However, what if I have a requirement where ID could be a string or a number, right? So first thought would be like, okay, then you will convert number to a string every time you call this function, or vice versa. This is not a best way of doing that. In theory, what you can do is you can have two functions, right, with the different data types. And now if you think like, okay, I have the function which accepts number and a string. But in TypeScript, you do not need to have different function which differ with types. You can use a pipe operator. You have a pipe operator and you specify what kind of type this function can accept, number or a string. So remember, double pipe is for or condition, single pipe is a union. So something like if 100 or 200, this is our if condition. Here you can have this kind of or operator, and union operator is single pipe. Okay, so far so good. What if you have a class? I say, oh, I didn't run this application. Let me run it. And I get this output, right? 100 with string and number. If you have some special requirement, let's say you want to handle a condition that if type of ID is string, you want to do some special handling here. So console.log handle string ID here. Otherwise, your handle number ID here. Now, if you run this, you should have two output. When you call with a number, you will see handle number is called because the type of ID is number for the first 100 as a number. And when you pass 100 as a string, we get a console.log of handle string. So this is how we can handle some special condition of types. You might see when you go to Angular application, you will see many times a class definition, something like, let's say, user service, and you will have a type, for example, say ID of type number or string. And of course, this I can mark it as optional, which I can initialize later, or you can have a function. Let's say we are saying get public get user details by ID of type number or string, and it shall return something like user array. So let's define an interface here, interface user, and here you can have user properties like name and string. So you expect to return user array or null. Oh, sorry. Okay. pipe operator, right? So what does it mean? Let me just resize it a little bit. It wouldn't. So here, if I return empty array now, this is a valid function here because this function returns empty array. Or I can return null. Okay, so this is how you can use the pipe operator for different types. Okay, what else we can do? We can do something like this. Uh, let's say we have an interface called user with ID as a number. Actually, let me open JSON users format. We want to represent this JSON object into a type. We tried in other video, but as you can see, there are many properties, right? We have ID, name, username, email. So let's start with number, name, email, string. So whenever you want to create a new user instance of type user and you try to set a value, one name is equal to user one and email is equal to user one at email.com, some random values, right? So what happens is like, if I do not provide one of the property here, I will get an error that types are missing. When you create interface, all these types should be initialized when you create instance of this interface. If you want to mark it optional, what you can do is you can say this property is optional by following a question mark. So when you create a new instance, you do not have to specify this value. You can, which will work fine, but if you do not, it won't complain about it. Another way of doing it is, let's mark it again required. And here I will say it's a partial of user. And I did typo again. So partial is a keyword from TypeScript, which allow you to take few properties of this interface and allow it to set it. So we don't have to change the definition of interface for to say, and we have our object set here. So if I now console.log user, I should get an output with name and ID only. So this is the partial keyword we saw. Okay, what else we can do? Partial, interesting. Now, if you have worked with C# or JavaScript, you may be aware of the dictionary type classes. Like you can have map, hash set, you know. If you want to do something similar in TypeScript, you have a couple of options to do that. First thing is a map object. Let's say we want to define an interface called icon, and that would be like icon number, ID is just number, name as a string, and color. Wait, color as a string. Okay. This is my simple interface. All three properties are required here. And I will define a new class, say mat icon, dummy mat icon from material design. In this one, I want to have a private icons of type map. So I will say map of string comma icon is equal to new map of type string comma icon. Okay. My use case is I want to create something like let icon mat icon is equal to new mat icon, and I would say let save icon is equal to, I want to pass mat icon dot get icon a key called save here, and console.log save icon. Meaning, I would expect there should be some kind of icons defined here, and based on the key, I should get the whole object. So let me try to define that map here. First thing I will say, first key is string, so I will say save as my key, and the value would be object of type icon. So icon would take ID1, name would be save, and color, let's say primary. So this is my first entry in my map. Second, third, I would just go with save, let's say new, I would say new color secondary, and let's say delete is danger, delete. Of course, ID has to be changed again. Okay, so we have got our icons ready, and let me just zoom out a bit so that is here. And let me clean the output here. Let me refresh the page. Logs, no logs, correct, cool. So what do we miss? We miss the implementation of getIcon function. Let's create a function called public getIcon, which will accept a string. So it would be like icon name as a string, and it should return icon, right? Or null. If you do not find it, it should return null. Now I could say return icons this dot icons dot get, and here I will just pass icon name, and this should return you the value of the icon object. However, is giving you error that icon or undefined is not set. So what we can do is we can use as operator icon. So we are explicitly saying the return type of get could be icon or undefined. So I'm saying I want it to be icon only. If it cannot, then it will just return null. So now we have the object here, and now let's run it. And we got the key object here. Similarly, if we pass, let's say delete now, and let me rename it just icon, clean the output, and we got the object. So in TypeScript, this is how you can manage your dictionary keys, key value pair, which is very handy when you are working with a large data set and you want to retrieve object based on the key instead of traversing the whole array one by one. There is a different way of doing this. What you can do is you can define private icons is equal to, or you can say soft type record string and icon. And a record is a another type provided by TypeScript where you can define key value pair. So here what you can have, the first key is save. So let me take this here, save, and I will mark it like as a key here. So this is not key here like this. And second was new, third was, and okay, you can see new is reserved. So we need to rename these keys to, let's say, okay, open. I will say open icon, secondary. Here I would say remove is one, again typo. I miss my editor. 3 and open is here and here is remove. Okay. Now what you can do is you can have your public getter method again here, and instead of returning icons here, you can directly say icon name here. Now if I pass remove as a key because delete was used here in the key, clean the output, run the application, and we got the object again. If I pass open, run again, I get open object here. So this is how we can use the key-based value access. Okay, we will check other feature in next video then. Thank you.